Imagine a person holding a basketball out of their second floor window above their patio. What will be the basketball's energy? How does that change as it falls and just before it hits the ground? Let's step through this together. We will calculate the basketball's kinetic energy, potential energy, and mechanical energy for each position in the diagram. The mass of the basketball is 0.51 kilograms. Assume that there's no friction and that the mechanical energy stays constant. So whenever you get a problem like this, you first need to create a data table. And the data table will really help you complete this task. So what do we know? Well, we do know the three heights that we need to calculate our kinetic, our gravitational potential energy, and mechanical energy for. So let's fill that in. The highest height is 5, then 2.5, and 0. The next thing to consider is our equations. We have the equation for kinetic energy, for gravitational potential energy, and for mechanical energy. When you're looking at a problem like this, the first thing you like to do is you want to look for the zeros. And by zeros, I mean you want to look for whenever the velocity is 0, because anything times 0 will be 0, or when the height is 0, because anything times height, m times g times 0, will be 0. So if we look at the diagram, up here the ball is being held still, so we can assume that the velocity is 0 there. And when the velocity is 0, the kinetic energy is 0 there. So let's put that in there. We also know that when it falls, it gets to the bottom here, the height is 0, so our gravitational potential energy will be 0 over there. Next, we're going to calculate the gravitational potential energy of the basketball at 5 meters. And for that, we're going to use our equation. The mass is given as 0.51 kilograms. The g is always 9.8 and the height is 5. So if we plug that into our equation, we get 0.51 times 9.8 times 5, and that will give us 25 joules. So that's at the height of 5 meters. Next, we have our very convenient equation. Mechanical energy equals kinetic energy plus gravitational potential energy. So kinetic energy plus gravitational potential energy. So at the 5 meters, 0 plus 25 is 25. We've also been told that there is no friction and the mechanical energy stays constant. So we can also fill those two out. So with very little effort, we have, and just reasoning skills, we have figured out a lot of the energies in the different positions. Let's take another one that we can complete here. Something plus 0 is 25, so my kinetic energy also there has to be 25. So all that we're left with are these two in the middle here, halfway down. So some of you may immediately see, well, if it's halfway down, it has to be half of the gravitational potential energy, but you can also plug in the numbers. So at the 2.5 meters height, my GPE is the mass of the ball times 9.8 times 2.5 meters, and that will give me 12.5 joules. Again, we're using our mechanical energy equation to figure out what the kinetic energy is there, and something 12.5 plus 12.5 is 25. So you see, we have now figured out all the energy levels at the different heights where the basketball is falling.